All right, Ben, what are we talking about today?
Today we're talking about this, that in JavaScript, everything is an object.
Well,
and
you're going to have to prove that to us.
We mean everything. Even the things that you would normally think of as primitives in the language, like numbers and, I guess...
Booleans.
Booleans. Booleans are objects too.
They are? Yes, they are.
And strings, all of the basic stuff, they're all objects, and they all inherit from their own object prototype, which we'll show you later you can munge around with. So,
well, give us an example. So how can you prove that a number is an object in JavaScript?
All right. So let's start with the number 4. If you open your JavaScript console in Chrome or anything else, you can do something like this. 4, you have to wrap it in parentheses, say dot, and then you'll see that Chrome shows you a bunch of methods and properties that are on this number, 4. And there's some, like what we were looking at them yesterday, there's
toLocalString,
toExponent. You can have the JavaScript interpreter give you a locale string of 4 million, or let's see,
4,000
in an American localized string or a Brazilian one, because in Brazil, actually most of the rest of the world, the 1,000 separator is a dot and the decimal separator is a comma. So JavaScript already knows how to do this on the number.
Because it's an object.
Because it's an object.
So how would you write that? Do real quick, show us even with the 4,000 and do the parentheses and show how you can say toLocale and then and they'll try it on their console. They'll be your debugger.
You can do 4,000.23. Okay. Dot. Oh, I don't remember what it is exactly.
It's toLocalString. So yep.
To.
Perfect. You're doing good. There it is. They're gonna test you.
And then it's the parameter here is a locale identifier. So you can do.
It's en-u. Oh, what was the Brazilian one?
If you're in the U.S., it'd be en-us.
Of course, in a string, you might want to. There you go.
The whiteboard doesn't throw syntax errors. And that'll give you what you expect. 4,023. Now, if you change this out to be
what was that Brazilian one you did yesterday?
BR-PT for Brazilian Portuguese, you get 4,000. Oops. For dot, comma, 23. That's a locale specific string. Oh, speaking of which, see, now it's a locale specific string.
What's interesting is that you see a lot of people though, they don't even know that numbers have this functionality on them, and they end up building themselves, you know, that you'll see a lot of times people doing the toFixed and saying decimal 2 and not really realizing that they could get the prettiness and the rest of the shebang for money based on that single method.
Right, because it's already there. We should explain really quick. I said you had to wrap it in a parenthesis. The reason for that, and this only applies to numbers, but if you have a 23.toLocale whatever, you're going to get an illegal identifier or something or other error. Because the JavaScript interpreter is going to come this way, see the dot, and think you mean a decimal, not a property accessor. So by wrapping it in parentheses, the interpreter knows that this is the whole number, then you can start doing property accessors on it.
Correct. So it's not like the parentheses are casting it into a number object. That's not it at all. Because you can say var x equals 23 and then say x dot, and now that we know that we're doing property access, it will allow you to do the toLocale string.
I think this is legal too. 3.141 dot whatever you want.
So as long as it doesn't anticipate another decimal, you're saying that.
Right.
I'd like to try that. I didn't know that.
Try that.
So let's talk a little bit more now. We're kind of getting ahead of ourselves because we're saying, well, everything's an object, but we haven't described how the prototypal inheritance works. But we're going to talk about that right now because what's really neat is you know that works because you can augment the number with some really cool stuff.
Yeah. So. Never actually done this in real life because I can't think of a good reason that you'd want to. But it's interesting to know that you can for numbers and for any other kind of object. And does number inherit from object?
Yes. Yep.
Well, that's good to know too.
Yep. So you have all that prototypal chain. If you look at it, you have an object dot prototype. And you have the number prototype inherits from this prototype, so then you have a number dot prototype. And so what happens is when you come on this number, so let's say when you're trying to access some type of property on a number, it's going to go up this prototypal chain to see if this first prototype has it, and if it doesn't, it'll check the next. And even before then, it actually checks the local object. So the first try, it's going to try to get that value or that property from the object. If the local object doesn't have it, then it goes and says, well, what type are you? Oh, you're a number. Let's go check the number.prototype for that property. And then so on and so forth.
Prototypal inheritance it's not unique to JavaScript, but JavaScript is pretty much the only language that gets used much that uses this pattern. So if you're not familiar with the prototypal inheritance method, we'll talk about it in another video more in depth. But every object inherits from a prototype. So every object has a prototype, even the number. You can actually do this with your number 4 dot prototype. And you'll get something there. I think if you hit enter here, you'll get number, right? It'll say,
you wouldn't get number in that case because now you're the instance of it. So you would have prototype on that, but it's not. It's on the function that you're looking for.
Oh, that's
so.
Right.
That's just a.
So yeah. So everything has a prototype. This 4, you can think of prototypes as cookie cutters. This 4 was stamped out of the number cookie cutter.
Correct.
And the number was stamped out of the object cookie cutter. So anything that the object has and the number has gets pushed down onto your instance of the object. And this is how inheritance works in JavaScript. It's a little goofy.
It's a little goofy, but if you come
really
from
cool.
a C# land, it's really interesting because what prototypal inheritance reminds me of, and I bet a lot of C# people are going to just cringe when I say this, but they're extension methods, essentially. It's a way to monkey patch, and a lot of programmers think that that's just an abomination from hell. But monkey patching, that's exactly what extensions are inside of C#. And it also allows you to do that in JavaScript through the prototypal inheritance. It's really cool when you really need it to work.
And there's a similar thing in Objective-C. It's called something. But you can do this in Objective-C too, where you tell the language, I know you know what a string is already, but I need all of my strings to do this extra stuff. So you can glue extra functionality onto every string in the environment. And that's what prototyping allows you to do. So why is that important? Well, if we go back to our number, erase this.
Yeah.
And I'm going to pick a new number. Say there's some need in our application for every number to have some magic ability, and we'll pretend that we want to be able to square numbers easily. So what we can do is we can go to the prototype of this object, which is the number. number dot prototype. Now this gets me the cookie cutter that all numbers are stamped from. Then I can start adding stuff here. I can say dot square equals
Perfect.
a function, whatever. And so this function can return the square.
Okay, so now keep that there for a second. Do you mind if I borrow this?
Oh, go ahead.
So let's do this in order. This will kind of puzzle you. You'll notice if we did this in your console and said var x equals, or let's just do the pi, right? 3.14. And you notice that we didn't declare this function until after this. But pi still inherits from that prototype, and you can come down and say right after you've told it that it now has square, that pi square, not pi, yeah, I guess that is pi. Pi square, and that will return I don't know what pi squared is.
6.28.
Thank you, 6.28. So that the beauty of this is that even though you've declared a number before you've augmented the prototype, anything that is that number will be given that functionality.
So if this still looks pretty normal. We have a variable and it has a method on it. That's pretty normal. Remember this, pi is a number. This is the same thing as saying 3.14 dot square 6.28. You can now square any number in the JavaScript environment because you said you should be able to.
Exactly.
All right. Now,
but that also applies. So let's go a little bit now that we've kind of hacked numbers to death. Do you want me? You can do that to all the primitives. So the beauty about, no, I guess the beauty and the awful part of JavaScript is that you have very few primitives. You've got string. Okay, you're gonna have to help me, Ben. You have boolean. You have number.
date.
You have object. You do have date. I'm not sure if I'd call that a primitive. It's an ugly thing.
Date's a weird monkey.
Let's see. I think that's.
And does function count here?
Yes, we should do. Well, to me, this should be gone and function should be here. You know what we should do? To me, in JavaScript land, function is. If we could write these in order, it would be object and then function, because functions are first-class citizens in JavaScript, and that is exciting, and we'll go through that in depth. But we have, this is what's nice, is you deal with a lot of languages, and they have long, and they have int and float and decimal, and I mean, yeah, double is what I meant to say. Just tons of choices, and JavaScript gives you one. So. But there's reasons for this when you want optimization and accuracy. And the numbering system of JavaScript isn't that great. We can go into that one of these days. But it has its flaws, and people that are doing shopping carts on your website, beware. There are some goofy things that will happen. So what you do is you just times it, get it out of the decimal, and then you put it back in the decimal after the fact.
Yeah, what is it? 0.01 plus 0.01 is not...
0.02 plus 0.03, I think, is not. Try that out.
0.02 plus
0.03 is not.
Oh,
no,
it is.
There's something in there.
I think it's multiple.
Well, we can't figure it out. It's one of those. But just beware that when you're messing with numbers,
be careful with your decimals.
Your decimals will get you. But this is the foundation that you have in JavaScript, and not only can you do great things on all these things, but this right here is an exciting feature. And I remember when I learned JavaScript first, and that probably wasn't the best thing that I could have done, because I went to other languages and felt so restricted and thought it was a nightmare. And but when you realize the beauty of functions and passing them around as first-class citizens, and they don't have to be part of an object, it really starts to shine. So all these things you can do that prototype thing with, but these are what you're given. Anything else you'd like to add?
No, let's talk about functions.
Okay. Yeah, let's do it. So functions. What do we want to talk about functions? Here's something that puzzles people. You can say var, let's do a couple of things. Let's say var num equals 8. That makes sense to most people, right? Let's do another one. Var equals narcissist, apparently. And that makes sense to people. Most people and most developers. And you could also say your, I'll just say B for bool. That makes sense to people. But this is where you get them. When you say var function equals function. And you could have it just return something great. Let's have it return string. So that right there is what puzzles people. But I want to focus on a lot of things in just this part. They call this lexicoscoping, I think is the terminology. But the point is that this function, wherever it's declared in line, it understands the scope in which it was declared. So all these things up above it could be used and accessed through here.
Okay, before we get into that real deep, I just want to drive this home. Anything you can do with any of these variables, you can also do with the function. You can pass it as a parameter into another function.
So show us that. So what do you mean by that?
Let's see, what's a good example?
Just pass it and make
All
a
right,
function or something.
Var foo. Someday I should find out where foo and bar come from. Equals function. And this is my plea to the JavaScript standards committees. Please give us soon a shorter way to write function. Let's see, var foo equals function, and it takes a parameter f.
Yes, this is so cool. This is
and it's going to do something. So when I invoke this function, am I still on the board down here?
I think yes you are.
I can say foo and pass in my function.
So what would you do with that function inside that foo? That's crazy. You're passing a function.
You can call it in there. You can.
So what if you did a console log f invocation? What would happen inside of foo here?
Oh, in here?
Yeah. So if we want these people to try this here.
Console log f. Remember, f is a function, so we can go ahead and invoke it.
And bam.
So, look, f is this function, so we'll invoke it. It returns a string. The string is going to come back here into the console log, and you'll get Jared out in your console. Now imagine that this foo and this fn were in two totally different places in different files. And then it's awesome.
So what you're saying is it doesn't matter where they come from. These don't have to be lined. Ooh, there. Almost killed myself there. These don't have to be right after each other. This could be in another page, in another file. It's like saying, for example, using a jQuery file and using its goodness. And that's the beauty of jQuery. A lot of times you want to know when something's done. You pass it a function to be called when you're done.
Oh yeah, callbacks. This is why callbacks work. So you can say, just do an oversimplified something, do Ajax, and then some data. I suppose we should talk about object literals at some point. And then callback. You've probably seen this pattern before, but this callback is just a function, so we'll just save some time here and say function D and then do whatever we want with
when that's done
with the D. So this function is going to go out and make an HTTP XML HTTP request, which doesn't happen immediately. It's going to go off, take its sweet time doing it, and when it's done, it'll call us so that we know. This is possible because a function is an object. It can be assigned to a variable and passed around.
So,
and that's really powerful. This is what makes JavaScript awesome.
it is.
Go ahead.
Well, no, I just thought that we could actually write something real quick that would show you that so you can do it in your console. Here's a quick little test that you could do. You could say var delay greeting, and that equals. This is where it gets fun. So what we're trying to get across is that functions can be used as variables. They're just first-class citizens. And so let's create a greeting here. And let's say we want to pass it the name of the person we're supposed to greet. So we'll have a name here, and then we'll say here's another cool thing. Not only can you pass functions in, but you can return functions. So I've already gotten a step ahead of myself. I got so excited. I want to show you how cool functions are. So what you can say is, I want to delay the greeting. Let's do this. Let's create something a function to send back. So this is another function that we're going to return. So we'll say fn equals a function. And then let's say we want, while setting this up, you can say how long in milliseconds the delay is. So at that point you can say, okay, I'm going to have it when they invoke this. There's a thing in JavaScript that says you can set time, this is lowercase, don't want you to get confused there. Set time out. Have you send another function. All these functions are going to make you dizzy. And then you say, I'm going to console log, so let's console log the name. And we want to do it in the milliseconds that we sent. Finish this off, and we can return the function. As you can see, that right there, how we used a function and returned it. Well, you said, well, why is that? Why is that useful? And you said we can still see down here, right?
Yep. You're good.
So down here, we could actually say, I want to create a greeting, but I want this greeting to be somewhat delayed. So we'll say this is greeting 1. Well, you'll notice that it doesn't get delayed. It doesn't even start the delay until after you get the function back, and it doesn't start the delay until you invoke the function. So I can say, here's the greeting equals delay greeting, and I want to delay it, and I'm going to pass it in bin, and I want to do it in 2 seconds, which is 2,000 milliseconds. That's going to give me back the greeting function. So let's do this. Let's call this the greeting function, right? So now down here, I can say, well, I can pass this around. So this doesn't have to happen immediate. This could be somewhere else on your somewhere else. So somewhere else you can say, I want to now have that delayed greeting. So greeting function invoke, and that will go, and you'll process the rest of the code that's down below, but in 2 seconds, all of a sudden your console log will say, poof, hello bin, or it won't even say hello bin, it'll just say bin. But you could, let's do that, let's do that. Hello space plus name. So now that'll say hello bin. So now I just totally went way further than I'd like to, but
all right, let's step through it. So the first thing you do is you define a variable, delay greeting, and that variable is a function, and it's just got all that stuff in it. It hasn't done anything yet. None of this has even been interpreted.
Correct. It's just lazy execution is what they call it.
If you put a breakpoint right here, is going to get skipped right over after this. So none of this actually happens. So then you come down here, and we're going to invoke the function in the variable with some parameters. Those parameters go down in here. And so now this part, let's see.
Yeah, from there.
This line.
Down right above the return.
This is actually the same line. This part gets invoked, but nothing in here has actually happened yet. You can put a breakpoint here, and it's not going to get hit.
That's because right here you'll notice that right here we're declaring. This is a declaration of a function. This is a declaration of a function. It's not the invocation of a function. It's simply the declaration of the function.
So when we called delay greeting with these parameters, what we've done is actually configure this other function that we make and return it. So now, what is it? Greeting function.
Yep.
This is this configured version of the function that got returned. All of this scope and stuff is retained. The milliseconds in the name, that's all retained inside of here. Not until we invoke the greeting function does this part actually get executed. Actually, this part gets executed from here to there. And then, not until
the millisecond.
2 seconds later, does this part get executed. So we wrote everything in a line like this, but it got executed here, and then here.
Yeah, just do numbers. Let's see numbers, because I think that's going to help them. And if you're at home writing this out in your console, write this out in text editor and paste it in there, and then breakpoint it, and you'll see that we're not telling you a lie. So that it's hard for developers a lot of times coming from other languages to not see the linear path. It's not linear at all.
So this is the first thing that happens. We declare that. And then the second thing is this.
Yep.
Then we execute that, making this
the third.
3.
Correct.
The return is number 4.
Correct.
The invocation of this variable is 5. Now at this point, okay, no, we do this. 6.
Yep.
Is your brain in a knot yet? Now at this point, the interpreter is going to stop here, can come back down here, and it's just going to do whatever.
Yeah, do 7 down there, because it's good to know that you need 7 is done before even the console log there. The hereafter. We can call 7 the hereafter.
Clear to who knows what. And then finally, the last thing that's done is right here.
So if that didn't get your brain in a knot, when you come through from another language, this does not make sense. But this is also what gives you power, because you don't know when these functions are finally going to be fired. And that's what creates the power of JavaScript. This is what allows the browser to continue on. It's single-threaded. So if you were to have something say, hey, I want this done now, and I'm going to wait until it's done, and you go to the server, your whole screen would freeze up. Callbacks, like here, all these have enabled us to have delayed, what they call delayed or lazy execution of functions. So we declare, the declaration of a function is far different than the execution or the invocation of a function, and that's what we just declared.
It's really important to remember that your JavaScript interpreter can only do one thing at a time. There is no such thing as threads or processes in JavaScript. It's all one thread, one process.
Correct.
So doing stuff like this allows us to let go of the execution thread and give it back to something else in the browser.
While we're waiting on the server.
Or while we're waiting on the server for other stuff to happen. There is actually a synchronous version of the XML RPC, XML HTTP request.
Don't do it.
But you don't use it, because if you do, the request goes off, your browser freezes.
And then it says, warning, your application is unresponsive.
You have a long-running script. Close it. So this is just how we deal with that.
So I'm not sure how long we've been going, but maybe we've done ourselves here.
29 minutes. I'm going to do one more thing.
Okay.
One more bit of mind blow. I'll speed this up in post.
There you go.
Okay, remember that functions are objects too.
Correct. So are you going to wow us?
I can say var fn equals function console log. Hi there. Okay, we're pretty comfortable with that, right?
Looks easy.
Okay, I'm going to declare a new variable. Var obj equals an object. I'm going to use just the object literal. I'll have a name. Name is Bob. Okay. Still with me?
I'm still with you.
Okay,
I'm
so
liking
this object is just an object, right? So we can say obj dot new prop.
Oh, you're saying you can
equals,
just add to objects in JavaScript?
Oh yeah, see we didn't say that this object had a property called new prop, but I can just add one willy-nilly.
So you're just augmenting it on the fly.
Yeah.
Okay.
So I can, I don't know, blah. So now my obj has a new property called blah, and I can fill it up with whatever I want. I mean, it's really the wild, wild west. So you can even say, you can treat it like an array and say object bracket 12 equals
something.
Function.
There you go. Number 12 is a function on this object.
And do whatever I want in there. Totally legal. Okay? Now remember that at the top of the prototype tree is an object, and under that is everything else, including function. So everything I can do to an object, I should be able to do with a function.
Correct.
So this too, remember fn, is totally legal. Fn dot age equals 14.
Wow. So what you're saying then is if you can augment function on the fly, you could probably even say, let's say instead of hi there, just say fn.age is what you're saying. What would that say?
That would throw an error because fn isn't in the scope here.
But it is. That wouldn't throw an error.
Oh, I guess it is. You're right.
So this is where it gets really interesting is functions declared themselves. So if fn is declared, remember everything inside this remembers the outer scope. Fn is in the outer scope. It can then reference properties that have been added to it.
Okay, so this is a function, and what you should do with functions, what most people do with functions, is invoke them. So we'll just invoke this, and we'll get on the console.
Just 14 right now.
It's not
Because
even
I changed your code right underneath you there.
It's a 14. Yep. I don't know what, this always feels weird to me to put properties onto a function and then turn around and invoke the function. You could even put, as long as we're at it, why don't we just go ahead and say this function has an array access property of 42 that is a function.
We're getting wild now. What are we heading into?
And then say, you could even invoke it, or you can say function dot, or not dot, 12, and you could invoke that.
Yes, you could.
Yeah, just because you can do something doesn't mean you should. But it's important to understand how this stuff works so that you can hack it. And so that when you read Jared's code, you know what it's doing.
Well, a lot of times you'll actually see these functions and you want to do something interesting with them. And for example, I ran into a problem where you'd say, why would you ever put properties on a function? And I had an opportunity and I took it. I'm not sure if I should have.
I did it.
And I did it, but let me explain what happened. So remember how the functions remember the scope. So what was happening is I didn't want to have this whole management system to unbind something. So
what do you mean by bind?
So I basically gave. We might be getting a little too deep here. But
tune in a couple of weeks for a video about functions.
That's exactly. I think we're getting too deep for what I was going to say. But needless to say, I actually made an unbind function on the function, and it knew how to unwind itself from how it was wound.
So your function had a property called unbind that was a function that would reach inside of your original function.
Original scope, and unbind itself from what was happening. So it was basically a teardown. It was kind of a dispose of sorts on that function. And so instead of having to go and have it stored in a hash or something, I just simply had the function and said unbind. And then it remembered how to unbind itself.
That's pretty cool.
Not always useful, but I did hack JavaScript that time.
But when you understand these things, that's when you get to start thinking in patterns that maybe you wouldn't normally think of coming from other languages. Things that C or PHP wouldn't let you get away with, that JavaScript does, that allows you to bend your code around in ways that at first may seem illegal and maybe immoral, but you start to realize these new patterns that emerge that make your code far more elegant and easier to read, easier to maintain, and a heck of a lot more fun to write.
That's right. Well, thank you, Ben, for explaining everything's an object.
You're welcome, Jared, for helping.
Well, we'll have another one that explains more functions in more detail. We're going to have a series of these things that are going to be far more advanced, but we want to start semi-simple so that people can follow along and then use JavaScript tactics of Ninja style.
Yeah, this is episode 1. This is our mission at Farpoint Station.
Farpoint Station. Right.
That's a Star Trek reference.
Oh, and I'm not geeky enough.
You knew that. He didn't.
I sorted as an artist. That was my problem.
But anyway, thanks for watching, and hopefully you'll come back next time.